Hello everyone, we are back with a new chapter, that is Principle of Mathematical Induction. Now you must be wondering, why are we studying this particular chapter, that is Principle of Mathematical Induction? So we have certain reasons for that, because it is that in mathematics there are some kind of an observations that we see, and we try to make some hypothesis, and on the basis of observation, when we make some hypothesis, after that we try to make theory, because this is how everything works. There are two kinds of observations. First is, there are two kinds of reasoning. First is deductive reasoning and second one is inductive reasoning. Now, what is the basic difference between what is deductive reasoning and what is inductive reasoning? You must have seen that whenever you throw some ball up in the air, it comes back to the level of earth. Irrespective how far or at which height you throw the ball or with which force you throw the ball, it will come back to the surface of the earth. So this is a kind of observation that we have seen. Now when we continue to see these observations, on the basis of these observations, we try to make some pattern, and on the basis of those pattern, we continue to make some rule, and on the basis of that rule, we try to make some theory. Whereas some people will use, this is one type of reasoning that somebody will give, that if you throw something up in the air, it will come back first time. Even if you throw it again, second time, it will come back again. And on the basis of this, when we see some pattern, on the basis of pattern, we try to make some hypothesis, and on the basis of that hypothesis, tentative hypothesis, we make some theory. Whereas some people will give reasons for this. They say that everything that is thrown up will come downwards to the surface of the earth because of the Newton's law of motion, that is because of Newton's law, that is gravity. Everything thrown up in the air comes back because of the gravitational force or the gravity of the earth, that it put everything back on the surface of the earth. So at first what we did was, we had some specific observations, and on the basis of those specific observations, what we did is, on specific observations, we tried to make some tentative hypothesis, and on the basis of that hypothesis, what we formed is new theory. So initially we had specific observation. On the basis of specific observation, we had tentative hypothesis, and on the basis of that hypothesis, what we formed is theory. Whereas in second type of reasoning, what we do, we have theory, and then we make some hypothesis, and then later on what we do is some specific observations. So here we are going from specific to general, and here we are going from general to specific. When we go from specific to general, that is known as inductive reasoning. Whereas when we go from general to specific, that is known as deductive reasoning. Now we will study these two types of reasoning in detail. So let's start with deductive reasoning. Okay, so in deductive reasoning, what we go is, we go from general, we give some general statement, and on the basis of general statement, we try to observe some specific things. That is, we go from general to specific. And over here we first have the theory, then we have hypothesis, then we have observations, and then we have confirmation. So this is a top-down approach. What kind of an approach is it? It is a top-down approach, because we are going from general to specific. First we had theory, then we have hypothesis, then we have observation, and finally what we have is confirmation. So this is a top-down approach, and this is called deductive thinking or deductive reasoning. So let's write the definition for this. It is deductive reasoning starts with a general statement and ends with a specific case. It proceeds from assumptions rather than experiences. So this is deductive reasoning. In deductive reasoning, we go from general to specific. First we have theory, then we carry on with the hypothesis, then we try to observe something, making the observation table or something, and then we confirm the theory that the theory which has been stated over here is it correct or incorrect? Is it following the thing which is trying to say, or is it not following the thing which is trying to say? So it is a top-down approach, which is deductive thinking. Over here we are trying to confirm the theory. First we have the theory, then we have hypothesis, then on the basis of the observations we confirm that the theory which we started with is a correct theory. So deductive reasoning starts with a general statement and ends with a specific case. It proceeds from assumptions rather than experiences. So this is what is known as deductive reasoning. Now we'll start with inductive reasoning. Inductive reasoning. So in inductive reasoning, first what we have is theory, then tentative hypothesis, pattern, and then observations. So these are the stages that we have in any kind of a thinking, but there is some difference between inductive and deductive reasoning. In deductive reasoning, we are going from top to bottom. That first we had theory, then we had hypothesis, then we have observations, and finally what we have is confirmation. But over here what we will follow is bottom up approach. First we had observations, then we will try to make some pattern. Using that pattern we will give some tentative hypothesis, and finally it is theory. So this is a kind of a reasoning where we are using bottom up approach, and it is called inductive thinking. It is something which is from specific observations, specific to general. We have some observations, we have some specific observations, and using those specific observations we are trying to deduce some general statement. So inductive reasoning works in the way moving from specific observations to generalization and theories. It is a bottom up approach. It is a bottom up approach. So let's write down the definition for it. It is inductive reasoning works in the way moving from specific observations to generalizations and theories. And this type of reasoning is known as this type of reasoning is known as inductive reasoning. So we till now we had studied what do you mean by deductive and inductive reasoning. In deductive reasoning, this is deductive reasoning. We are starting from general to specific. First we had some theory. On the basis of that theory, we are trying to derive some hypothesis, and then using that what we have is some observations, and finally we can confirm that the theory that we used initially is a correct story, or is it correct theory or not. So it is a top-down approach. In top-down approach, deductive reasoning starts with a general statement and ends with a specific case. It proceeds from the assumptions rather than experiences. Whereas next what we studied is inductive reasoning. In inductive reasoning, it follows bottom-up approach. First we have some observations. On the basis of observation, we form pattern, and on the basis of that pattern we give some tentative hypothesis, and on the basis of that hypothesis what we give is theory. So it is from specific to general. We have some specific observations. Using those specific observations, what we have is, using those specific observations, we try to generalize it and give our tentative hypothesis, and using that tentative hypothesis what we give is theory. So inductive reasoning works in the way moving from specific observations to generalizations and theory. This type of reasoning is known as inductive reasoning. Okay. Now you must be wondering, why are we studying this, and why we need mathematical induction over here. So there are certain rules, like if you will say sum of natural numbers, Sn. Sn is equals to n into n plus 1 by 2. So this is a general formula. How you can say that this particular formula is valid for all n, and where n is a natural number? So you are given some formula, that is Sn is equals to n into n plus 1 by 2, where n is a natural number. Now somebody said that this is the formula for sum of all natural numbers, but how would you know that it follows, it is true for every natural number? You can check it up till 10, 20, 30, 40, but what about 100,000? You cannot do that, because it is a very lengthy and tedious process. You will start from 1, 2, 3, 4, 5, 6, so on, and when you start adding up, it will become quite complicated and quite tedious. So in order to make that thing quite simpler, what we can use is mathematical induction over here. We can prove it for n equals to 1. When you will put n equals to 1, you can prove it for one natural number. So when we used n equals to 1, we can see that S1 is equals to 1 into 1 plus 1 by 2. So it is 1 plus 1 by 2. And in S1 is equals to only natural number 1. So S1 is equals to 1 into 2 by 2, which is equals to 1. Cutting 2, because 2 will get cancelled out with 2, so S1 is equals to 1, which is following over here. Now we will try to find it for Sm. Sm is equals to m into m plus 1 by 2. Now if I will prove, if it is true for Sm, it will be true, if it is true for Sm, using that it is true for Sm, I will prove it is true for Sm plus 1. So I will put Sm plus 1 into m plus 1 plus 1 by 2. So this is the formula which should come. Now we know that Sm plus m plus 1th term, because we have sum till m terms. When we have sum till m terms, now we are trying to go for S, that is sum for m plus 1 terms. So we have sum for m terms, we will use that sum for m terms and will add m plus 1th term in it. So sum for m terms is m into m plus 1 by 2. And the m, we will add mth term, m plus 1th term, which will be m plus 1. Now what we can see is, taking the LCM, m into m plus 1 plus 2 into m plus 1 upon, after we took the LCM, it is taking out m plus 1 common, what we are left is m plus 2 upon 2 further solving it. Now can I write m plus 2 as m plus 1 plus 1? That is correct. So it is m plus 1 into m plus 1 plus 1 by 2. Isn't it same as the above, that is s of m plus 1? That is m plus 1 into m plus 1 by 2. So we will compare these two quantities. First quantity is this one. Let's mark it 1. And the second quantity is this one. Let's mark it. So we can see that over here we can see that 1 and 2 both are equal. So if equation 1 is equals to equation 2, that means s of m plus 1 is also true, because previously what we proceeded with was that s of m is true. When we took sm is true, we added m plus 1th term to it, and by that we will take out the sum of m plus 1 terms. When we took out the sum of m plus term, it is satisfying the formula which we were given previously. So if we can see that it is over here, we can see that s of m plus 1 is m plus 1 into m plus 1 plus 1 by 2, and over here we can see that m plus 1 into m plus 1 plus 1 by 2. So both equation 1 and 2 are equal. So we have proved that s of n is true for m plus 1 also. So it will be true for Sn also. Sn will be true. So this is how we will proceed. First we will start with n equals to 1. If we will prove that s of 1 is true, yes, s of 1 is true, then we will assume that s of m will be true, and taking that s of m is true, we will add the m plus 1th term to it. When we will add m plus 1th term to Sm, what we will get is m plus 1 into m plus 1 plus 1 by 2. And by putting the value of m plus 1 in the Sn, it is coming out to be the same equation. That's why it has been proved that s of m is true, and provided s of m is true, s of m plus 1 is coming out to be true, and that's why it will be true for n equals to, for any n which is a natural number. So this is how we will proceed in our further questions also. That's why what we need is mathematical induction. In mathematical induction, we will try, what we have is some general statement, and we are going from we have some statement. We will first prove it true for p equals to 1. So over here what we will use is some statement. Suppose you are given with the statement Pn is equals to sum, like what we have used is n into n plus 1 by 2. So what we will prove is, first P1 is true, then we will prove that P2 is true, and then we will say that Pm is true, and using that Pm is true, we will prove that P of m plus 1 is. So initially what we had, P1 is true, P2 is true, Pm is true, and using Pm is true, we will prove that Pm plus 1 is true, and when Pm plus 1 is true, we will finally deduce that it is Pn is true for every natural number, for all values of. So let's revise. For what we have initially, we are trying to use some techniques, that is principle. We are using two types of techniques, not using, but we are studying about two types of techniques. First is deductive, that is in deductive reasoning we are going from general to specific. It is a top-down approach. Whereas next is what we have is inductive reasoning. In inductive reasoning we are going from specific to general. So it is a bottom-up approach. Inductive reasoning works in the way moving from specific observation to generalizations and theories. So here what we have is some statement, that is Sn is equals to n into n plus 1 by 2, where Sn is sum of n natural numbers. So we have Sn is equals to n into n plus 1 by 2. Sn is equals to sum of n natural numbers. we proved that it is true for S1 where value of n is equals to 1. So S1 is equals to 1 into 1 plus 1 by 2. 2 is getting 2 will get cancelled and S1 is equals to 1, which is S1 is true. Now assuming that it is true for m, so Sm is equals to m into m plus 1 by 2. We will add m plus, we will prove using that Sm is true, we will prove that S of m plus 1 is true. In particular this statement you can see that we are starting with Sm is true. So if we will add m plus 1th term to it, it will be n by 2 into m plus 1 by 2 plus m plus 1. So taking out LCM and after that taking out m plus 1 to be common, what we are left with is m plus 1 into m plus 2 upon 2. And when we will split 2, it can be splitted in the form that is 2 equals to 1 plus 1. So over here what we received is m plus 1 into m plus 1 plus 1 by 2. Now you can see that equation 2 over here and equation 1 over here, they are exactly same. When they are exactly same means using Sm true, we have proved that S of m plus 1 is true. And if it is true for S of m plus 1, it will be true for any n, that is any natural number. If Pn is equals to n into n plus 1 by 2, what we can prove initially is P1 is true, P2 is true, Pm is true, and using Pm is true, we will prove that P of m plus 1 is true, and after that we will conclude that Pn is true for all values of n. Thank you so much. This is our lecture for, this is the first lecture for mathematical induction, and in next lecture or in next class we will write some theory about what are the steps which I've kind of made you understand, which I've discussed over here using this particular example. But in next class we will write the theory for that particular steps and we will do some questions. Till then, take care and please study hard. Thank you.